Hey guys, Zong here, back in the math video. Today we're doing 2017 AIME 2, problem number 9. So without further ado, let's do it. So a special deck of cards contains 49 cards, each labeled with number 1 through 7 and colored with one of 7 colors. Each number color combination appears exactly one card. Sharon will select a set of 8 cards from the deck at random, given she still has a blah blah blah. The probability Sharon can discard one of her cards and still have at least one card of each card, and at least one card with each number is P over Q, or P over Q relatively prime positive integers. Okay. So the first thing that we notice is that she gets at least one card of each color and one card of each number. So obviously in her hand she has to have the numbers 1, 2, 3, 4, 5, 6, 7, 8. 7, and then she also, with these 7 numbers, she also has to have 7 different colors, like red, orange, blue, etc. But since she chose 8 cards, then she has to have an extra number. So without loss of generality, let's say this number is 1. Let's say she has an extra 1 in her hand. It could be any other of the other numbers. And without loss of generality, let's say the extra color that she has is red. Because she must have an extra color and must have an extra number because she chose 8 cards, not 7. So since the chance is same, since the probability of P over Q of being able to discard a card and still have one card of each color and one card of each number is the same no matter which duplicate number or color she has in her hand, we're just gonna, without loss of generality, say that she has 2 ones and 2 reds in her hand. So now we have to find the probability that she after she discards one of her cards, she still has at least one card of each color and one card of each number. So let's think about this. So first, what are the total number of ways you can assign the colors to the numbers? Well, the only cards we really care about are the ones with 2 ones and 2 reds. So what are the total number of ways she can assign the red cards to the numbers above? So what are the total number of ways she can assign these 2 red cards to the numbers above? So she has 8 numbers, and she has to choose 2 red cards. So that's just 8 choose 2. You have to keep in mind, you have to remember that she can't have both the red cards assigned to both the number ones, because there can only be one red card that has the number 1 on it. There are no duplicate cards. So it's actually 8 choose 2 minus 1. Now with these possible orderings, what's the probability that she has the red she has at least one of the reds assigned to one of the ones? So the probability that Sharon can discard one of her cards and still have at least one card of each color and one card of each number, that's only possible if the red is assigned to the 1, because then she can discard that one, the red number 1 card, and still have these numbers and these colors. So red has to be assigned to the number 1. So how many ways can that happen? Well, actually it's easier to use complementary counting in this case. We can just count the number of ways that when red isn't assigned to number 1, and that's if red is assigned to only these 6 colors. So out of these 6 numbers, so out of these 6 numbers you choose 2 numbers to be red. So that's 6 choose 2. And that's the complement of the probability that at least one red is assigned to 1, 1. So the numerator would be this. This is the total. This is the total, and this is the number of cases in which the reds aren't assigned to the ones. You divide this by the total number of ways again, you get 4 nines. So the answer is P plus Q, so it's 13. Pretty easy for a number 9 AIME problem in my opinion. So let's go over that again because it was a bit confusing. So without loss of generality, assume she has 2 1s and 2 reds. There are 8 choose 2 ways to assign these 8 numbers to the 2 red cards, but you have to subtract 1 because they both can't be assigned to the number 1. And then we need to find the probability that we need to find the number of ways that the red is assigned to one of the 1 cards. Because if a red is assigned to one of the 1 cards, then that means that she can discard one of her cards and still have at least one color, one of each color and one of each number. See. So we have to find the number of ways in which she can assign the red card to a 1 card, and we use complementary counting. So we find the number of ways that she doesn't assign a red card to a 1 card, and that's choosing 2 out of 6 of these numbers to be red. So 6 choose 2. So this is the number of ways in which she can distribute the red cards and have one of the red cards pair with one of the 1s. And that's over the total number of ways she can assign the red cards. And that equals 4 9s. So, pretty simple problem. I hope you guys have a good spring break, and I'll see you next week. Different exponents. And then set that equal to 1001. That seems easy, right? Well, you have to be careful because the resulting expression that include all 4 variables. So we can all 4 variables A, B, C, and D. So you have to be careful because that means you can't the terms in the resulting